Is it visible? Any one of you?
Yes, sir.
Any one of you? Is it visible?
Yes, sir.
This link is just now I sent to your WhatsApp group. 18ME 2001 batch on that subject. That is our WhatsApp group 18ME 2001. You check your WhatsApp group. This link is sent to you. Okay, MCQ on refrigeration and air conditioning. Okay. Already I sent MCQ on thermodynamics link. Now I send the MCQ on refrigeration and air conditioning. So refrigeration and air conditioning MCQ question and answer is available. Okay. Or you can just type MCQ on refrigeration and air conditioning. This link will come. Okay. Now we will discuss the air conditioning refrigeration question. Okay. This MCQ contains refrigeration and air conditioning question. But in this class we are going to discuss about the refrigeration MCQ. MCQ on refrigeration only. Okay, thermodynamics we already discussed. MCQ on thermodynamics we already discussed. Okay. So in this class we are going to discuss about the vapor compression refrigeration system. MCQ on vapor compression refrigeration system and refrigerant. Okay. And these are the topics we discussed in the previous classes. Now you see the MCQ. Here you see that the answer and the solution is given. Okay. So you guess the answer, find out the answer. After that, click this answer. For some question, explanation is also given. So the undesirable property of a refrigerant is. The previous class we discussed about the desirable property of refrigerant. Desirable property of refrigerant. Here the question is undesirable property of refrigerant. Any one of you guess and you guess it and find out what is the correct answer. Yesterday we discussed about the ideal property of refrigerant. Okay. Any one of you find out the undesirable property of refrigerant. Yes. Yesterday we discussed about the desirable property. You recall it. Desirable property, that means ideal property of refrigerants. Here 4 option is given. Find out the answer. Undesirable property is given.
High boiling point.
High boiling point. Answer D is the high boiling point. Okay. Non-toxic, desirable property. Non-flammable, desirable. Non-explosive, desirable. But the high boiling point is the undesirable property. Because when the boiling point is high, what will happen? You cannot get vapor. You cannot reduce the temperature of the refrigerant to lower temperature. So this is the undesirable property. So low boiling point is a desirable property. So explanation is given. It is very important that the refrigerant has a low boiling point. That is, it should have the ability to turn into gas, refrigerant gas, easily when it absorbs heat. When high boiling point is there, vapor is not generated. Vapor is not produced. If it has a high boiling point, the compressor will have to create too much of a vacuum in order to lower the pressure to make the vaporization happen. So the desirable property is low in boiling point. Otherwise, vapor formation is difficult. So this link is given to you. You click the link because the explanation is given. Explanation is useful to you. In some MCQ, without explanation, is answer is given. Next, the desirable property of a refrigerant is desirable property. So here you see that what are the low boiling point is one of the desirable property. High critical temperature, desirable property. High latent heat of vaporization, Desirable property, the enthalpy difference, Hc minus H. Enthalpy of vapor minus enthalpy of liquid. Latent heat of evaporation is nothing but enthalpy difference. Enthalpy of vapor minus enthalpy of liquid. So the difference should be higher, then only it absorb more heat from the surrounding medium. So it is a favorable one. High critical temperature is favorable one. Low boiling point is favorable one. So all of this is the answer. We will check it. So option D is all of this. Physical properties of refrigerant. This is a property we already discussed. Ideal property of refrigerant. Low condensing pressure, high evaporator pressure. In order to reduce the COP value, higher critical pressure, higher vapor density, high dielectric strength, high latent heat of evaporation, high heat transfer coefficient. These are the properties yesterday we discussed. The operating pressure for refrigerating unit using R12 as a refrigerant. Rayon 12 as a refrigerant. Operating pressure for refrigerating unit. So option B is 8 bar. What is this operating pressure? Operating pressure for refrigerant is 8 bar. What is this operating pressure? Operating pressure is a refrigeration unit is given. Refrigeration system is given. And Freon R12 is a refrigerant. Operating pressure, discharge pressure minus suction pressure, or simply the pressure ratio. You can put the pressure ratio also. Okay. P2 by P1, pressure ratio. Assuming that evaporator is at 1 bar pressure and the condenser is at 8 bar pressure, what is the operating pressure ratio? P2 by P1, discharge pressure divided by suction pressure. So 8 bar divided by 1 bar, that is 8 bar value. That means the condenser should be operated at 8 bar pressure. Okay. So here explanation is not given, but the answer is given. So here what you have to do is, there are 5 sections given. Section 1, section 2, section 3, section 4 and section 5 are given. First you have to check, click section 1. Okay. 5 questions will appear. 5 questions will appear. At the bottom you find that there are 5 questions here. Here air conditioning question is also mixed. Select the refrigeration question only. Okay. Air conditioning is also in the syllabus. We will discuss later on air conditioning after your internal test is over, midterm test is over. So here you see that at the bottom, different sections are there, 1 to 14. So each subdivision contains 5 questions. So 14 into 5 is 70 questions are there. Okay. So in section 1, how many questions are there? 70 questions. Section 2, 70 questions. Similarly, section 3, section 4. Section 5 also 70 questions. So total number of questions is 350 questions are there. Understand? So refrigeration and air conditioning, totally 350 questions with the answer and the explanation is there. Similarly, for thermodynamic MCQ also, section 1, 2, 3 are there. At the bottom, you find the subdivision. Each contains 5 questions. This link is already sent to you. Okay. Or you just type MCQ on thermodynamics. And then this type of questions will appear. Okay. We have to practice it. Okay. So now next what you do, you have to select 2. Now another set of 5 questions will appear. This ammonia absorption plan, we didn't discuss that. Air conditioning, only select the refrigeration question. Air conditioning we will discuss later on. In domestic vapor compression refrigerator, what is this? The refrigerator used in the kitchen, house. The refrigerant commonly used is. These are all refrigerant. This is carbon dioxide, CO2. Question mark is wrong. Carbon dioxide, CO2. ammonia, R12. So these are all refrigerant. But you have to find out the refrigerant used in the domestic refrigerator. What is this answer? Answer C, freon 12, R12, refrigerant 12. Another name is freon 12. So this is the refrigerant used in the domestic refrigerator. Ammonia is used in ice making plant. In refrigerator, the temperature difference between the evaporating refrigerant and the medium being cooled should be. So simply the temperature difference between the evaporating refrigerant means temperature difference available in the evaporator and the medium being cooled. Okay. Medium being cooled should be. What is the answer for this? Answer B, as low as possible, 3 to 11 degree centigrade. So what is this meaning? In refrigerator, the temperature difference between the evaporating refrigerant, simply the refrigerant that actually passes through the evaporator, and the medium being cooled. Medium being cooled means the surrounding medium. Okay. As low as possible, temperature difference, 3 to 11 degrees centigrade is required. Okay, simple example is, assuming that this evaporator refrigerant temperature is plus 5 degrees centigrade. Medium being cooled is the difference. Okay, this range. Within this range, the difference between the refrigerant and the medium being cooled. Medium being cooled, understand the material to be cool. It may be air or it may be water. As low as possible, 3 to 11 degree centigrade. So in refrigerator, the temperature difference between the evaporating refrigerant and the medium being cooled should be as low as possible, 3 to 11 degree centigrade. Okay. Cooling medium. Next, air refrigerant cycle, we didn't discuss about this. We will discuss in the coming classes. So today we will discuss only the vapor compression system. The value of COP, coefficient of performance in vapor compression refrigerant cycle, is dash. Value of COP. Value of COP in vapor compression refrigeration cycle is dash. Value of COP is nothing but coefficient of refrigeration system in a vapor compression refrigeration cycle is. What is this value? Always less than unity, always more than unity, equal to unity, any one of the above. That means always less. Unity means 1, always less than 1, always more than 1, equal to 1, any one of the above. You know the definition, COP is the ratio of refrigerating effect to work input. So what is this value? Answer is B, always more than unity, greater than 1. Understand? Greater than 1. COP in a vapor compression cycle is greater than 1. Okay. Next, the suction pipe diameter of a refrigerating unit compressor in comparison to delivery side. We know that the evaporator is connected to compressor, and then the compressor is connected to condenser. The compressor inlet is connected to evaporator, that is a suction pipe. Compressor outlet is connected to condenser, that is called a discharge side or delivery side. So simply pipe diameter is given. Okay. What is the option? Bigger, smaller, equal, smaller or bigger depending upon the capacity. So what is the answer? Answer A is given. Here you see that the suction pipe diameter of a refrigerating unit compressor in comparison to delivery side. Suction pipe diameter